Partial fractions is the lesson we are going to see today. Please don't forget to subscribe to the channel. So, partial fractions are going to be used in most cases when you're integrating. It's going to reduce some hard to integrate functions to easier integratable functions, as we're going to see. Now, a function f of x, like given like this, can be expressed as this, like this. We see we are separating it. Now we are expressing it in parts. That's why we say that this function now is expressed into partial fractions. So when you simplify this, you are going to get the same thing like this. So we say that now f of x has been expressed into partial fractions. Now partial fractions, you can have the ones with the proper functions or improper functions. What are the ones with the proper? Proper, these are functions when the highest power in the denominator is greater than the power or a degree in the denominator. So the degree of the denominator, not the degree in the mathematics, mean the highest power. So the degree of the function in the denominator should be greater, strictly greater than the power in the numerator. Then said to be improper when the degree in the denominator is less or equal. If it's less or equal, it's improper, and if it's improper, we are going to start with the first long divided to make it proper. Okay, then types of partial fractions, these are good depending on the nature of the denominator. So the denominators we have, the ones that gives us the nature. So we start with denominators for the linear factors. Now let us start with that. Now linear factors, you know the equation of a line. It means that all the variables, the s power is 1, odds to degree 1. In this form, x plus b. So the s power of the variable x is 1. Now, we express it in two partial fractions. I'm going to add this and the other one. Okay, so what we do, when they give you, see that this one is a linear factor, and this one is a linear factor. Remember in polynomials, you know why you're calling them factors. So it's that this one is x is power 1, and this one is x power 1. So these two, I mean this denominator is having linear factors. So that's why we said this one is linear. And it's proper. Why? Because here it's a constant. Here, when you expand these ones, the degree is going to be 2. So the degree in the denominator is greater than the degree in the numerator, because this one is its degree is 0. This one is degree 2. Okay, so what we do is say let B, some people use 3 equivalent signs, dA over x plus 1, then plus b over x minus. Why do we do this? So that you know this one is degree 1, it means that this one should be proper, this one should be to degree 0. So that's why whenever it's linear, the numerator is a constant. We are going to say this quadratic is going to be linear. So always the numerator should be powerless that of the denominator. That's why you see, whenever it's linear, this one is a constant. Why? Because when you have x power 0, you got x power 1, you got x power 2. So if the numerator is having x power 1, so this one is x power 1, means that the numerator is to powerless. That's why you get x power 0, which is a constant in simple terms like this. This one is also, that's why you say it's a constant. Now, from here what we do, we get the LCM. You see? To get the LCM of these two, what you do, you get the first, you get its numerator like this, plus the second is numerator like this. Now we get the LCM. The LCM, we are multiplying these two. So when I cross multiply, you see that now I'm going to be adding now 15. Sorry? I'm going to be adding this as, okay, I'm going to be adding 15 over equaling to now, when I cross multiply this here, the all over this times this, x minus 4. Now it's that this and this, we can cancel them, because multiply them by this, they are going to cancel. That's why now we have 15 equaling to n into x minus 4 plus b into x plus 1. Now so we have one equation, but we have two unknowns, and that one will give us infinite solutions. So our task now is to eliminate one of these unknowns, the A or a B. Eliminate one. So you see, if I want to eliminate this, I want now the whole of this bracket to be 0. So what I say, if x minus 4 is equal to 0, so that I eliminate this A, so that I can get B. Because if we have two unknowns, you need two equations. But here we have one equation. It means that I want to eliminate one of them, all of these unknowns. That's why I remove this. When this is 0, it means that this is going to be, the whole of this will be 0. So I'll be having one unknown and one equation, which I can easily solve. So when this is 0 start, when we solve this, is that our x is going to be a 4. So when x is 4, you put a 4 here. So this will be 15 equal to 2. When I put a 4 here, or I say the whole of this is 0. So 0 times this is 0. When I put 4 here, they have been going into 4 plus 1, which will give me 5b. So start from here, my b is going to be a 3 if we divide 0 by 5. Now, after getting b, you can now come and now you want to get a. So you create this. So in simple terms, you put the value of x to be the one which is similar to this but opposite to the side. Or what you can easily say, when x plus 1 is equal to 0. If you take x to the other side, so our x is going to be a negative 1. So if x is negative 1, now we substitute here. So I'm going to be having now 15 equal to 2. A into now negative 1 minus 4. Where in this x we put negative 1. When I put here negative 1, you see that this one is going to be now plus b into, but we say the whole of x plus 1 is 0. So that we have, from here we have 15 equal to negative 5a. And the if you divide the 3 here, you get negative 3 is equal to our a. So after getting this now, you come and you write this again. So now my 15 is identical equal to my a, which is negative 3, the whole over x plus 1, then plus my b from here is 3, the whole over x minus 4. So here we have expressed this into partial fractions. Now I'm going to handle this later. Let us first handle this. Now, so this one is linear because it's power 1. This one is quadratic because it's power 2. Like the degree is 2. That's degree. I mean the highest power is 2. So now we always first check, is this factorizable? You always check if it's factorizable, then you are good to go. So instead you can easily factorize this. If it's not factorizable, then you are going to treat it as a quadratic denominator. But you see that this one is factorizable. How? I can write x squared minus x minus 6 as x minus 3 into x plus 2. So this one is factorizable. Why? Because it's factorizable into two linear factors. So sometimes they hide linear factors in quadratic expressions. So you first check, is it factorizable? It can be difference of two squares, or it can be in this form. Or is you first check if it's factorizable, then you express it into those linear factors. Now I can write the whole of this as now 11 x plus 4. The whole over now this is there as x plus 2. Then this one 2x plus 3. Now is that all of them are linear factors. You see this one is power 1, power 1, so that is also linear. They were just confusing us. Now you say if they are linear, means that the denominators are going to be constants. So you say, let the whole of this be now a over the first plus b over the second plus c over the third. As simple as that. Now you see that I can get the LCM as we did here. You multiply this and this and this. So now, you see that after multiplying, always this LCM is going to pass as we saw from here. That this one is transferred on this when you multiply through. So now, you take this side I'm going to be having now, 11x plus 12 equaling to now the LCM, we have seen that our LCM from here is the product of these three. This times this, you get this. What you do is say, this one goes in this how many times? In simple terms, you get this, you divide it here, so what is remaining is going to be this and this. So this one is going to be now A into now, this is here. So this one, you divide this here, you get x plus 2, 2x plus 3, then plus a b. You see that this one else, the denominator for this is this. When you divide it here, you remain with this and this. When I come to C, so when I divide the C here, this denominator is here. When I divide it here, so when I divide it here, this will go. So when you cover this, so the remainder is this as x minus 3 into x plus 2. It's not our denominator, of course, it's always plus 1. That's why now I'm skipping that step. Now here, the same idea. If you want to now, you see that you have 3 unknowns, but you have one equation. It means that you have to kill off 2, so that you have one unknown and one equation. So start with what I have is a common factor. So this is common here, and it's common here. So this is common here, and it's common here. So that's how we kill them off. So if I want to get A, now I have to set this to 0 and this to 0 so that I can get A. If you want to get B, you set this to 0. I say past that. So if I say if x is equal to now the opposite side for this, which is going to be a negative 2. So if x is negative 2, or if the whole of this bracket is 0, when I put a negative 2, it's going to go to 0. This one is going to survive, this one is going to go to 0. Or if x plus 2 is equal to 0. So now, when you simplify this, that's why I get this. I put here 11 into negative 2 plus 12 equaling 2. The whole of this is 0. So that one is going to be 0. This is going to be 0. This is going to be 0. So what's going to survive is going to be b into negative 2 minus 3. 2 into negative 2 plus a 3. So this one is going to be negative 22 plus this 12 is going to give us a negative 10 equaling 2. This one is going to give me a 5. Yeah, this one is going to give me a negative 5. So here we have negative 5. Then here we simplify. So this one is going to be negative 4 plus 3, which will give us a negative 1. The negative 5 times negative 1, we are going to get a 5b. And from here, I see that our b, when we divide this side, it's going to be negative 2. So you have got the value of b. Now to get the value of a, it means that to get the value of a, you get this, you see you get a bracket is not here, and equate to 0. So this bracket is not here. So it said, if x minus 3 is equal to 0. It means that the root is going to be x equal to 2. You take this side, it's going to be 3. So when you put out 3, you're going to have 11 into 3 plus 12. We are putting in this equation. So here I'm going to be having n into 3 plus 2, 2 into 3 plus 3. So this one is going to be 0. Because I said x minus 3 is 0. So I'm going to be having plus b into 0 into here 2x plus 3, then plus c into 0 into x plus 2. So here we're going to waste time because this is going to be 0 already. So here this is 33 plus this I get 45 equal to 2. This one is going to give me 5. Here I'm going to be having this is 6. This is 6 plus 3, which is 9. 9 times 5, I get 45a. And from that side, my n is going to be 1 divided through by 45. When I come down to this, now it's like if you get C, we equate the bracket not here to a 0. So this bracket is not here. So now we equate this to 0. So if 2x plus 3 is equal to 0, means that now from here, our x, if we make x the sum that you get, negative 3 over 2. So it means that here I'm going to be adding now 11 into where it's x, we put negative 3 over 2 plus 12 equaling 2. Now this is going to be 0 because this is over 0. This is going to be 0. Then here I'm going to be adding c into negative 3 over 2 into negative 3 over 2 plus 2. So here we are having a minus, here I'm having minus 3. Here I'm having minus 3 over 2 minus 3. Then here I'm having negative 3 over 2 plus 2. Simplify this. You see I'm going to be having negative 33 over 2. So I have negative 33 over 2 plus 12. If I cross multiply here, I have negative 33 plus this side this will be 24, the whole over 2. When you simplify here, so we are going to be having negative, what should we add here? To get this, is that we are going to add there 9. So we add here 9, you get that. So negative 9 over 2. Inside we have negative 9 over 2 equaling 2. When you simplify this, is that we are going to be having negative 9 c into negative 9 over 2. What about here? We are going to be having, this is going to be 4. This is going to give us half. I think it's going to give us a half. Like that. As simple as that. So, it's giving us a half. This is 33, 24 over 2. When you add here 9, that's when you get this. Yeah, that's I think. Okay. So now, the rest is to simplify this. When I multiply this and this, is that this is going to give me negative 9 over 2 equaling 2. When we multiply this and this, we get this negative and this we get negative 9 over 4c. And from here is that our c is going to be, when you simplify this, is that our c is going to be 2. Because this cancels, that our c is going to be 2. So now I have the values of a, we have b, and now we have the value of c. Now, you come back and write this, or is you come back and write this properly. So now 9, 11, x plus 12, the whole over. Now x squared minus is going to be equivalent to our a. Our a is 1, so we have 1 over x minus 3 plus b. Our b is negative, so plus negative 2 over x plus 2. Then plus our c, which is 2, the whole over. Now 2x plus 3, and that's what we have there. Now, I'm going to give you a hint on this. This is the hint I'm giving you. Look at this hint so that you can solve that number in your free time. The hint is going to be, you see this one, we have x common here. So that I can easily factorize out x. So this will be now 6 minus x over x. You see x is common, I have x squared minus 4. And so now this one is quadratic, but I can express this as a difference of the squares. Because I know my x squared minus 4, the same as x squared minus 2 squared. And see, this is the difference of the squares, which I can write as x minus 2, then x plus 2. So now, these are now, you can easily handle this, because all of this is going to be now 6 minus x over x